Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both from Calgary, Alberta, Canada.
Thanks again to our Patreon subscribers. We really appreciate your support for our show.
Yeah, we love it when people subscribe to our show. If somebody was looking to subscribe, what would they get with a Patreon subscription?
So you get our bonus episodes. We have so many engineering failures that we want to talk about, and not all of them fit into the structure and the rules that we've made for our regular show that we share on all the podcast apps. So we make these bonus episodes, these different shorter episodes on different failures that either have really straightforward causes or not a lot of information. Some of them happened a really long time ago. So we have episodes dedicated just to these failures. They're pretty straightforward episodes. They're, like I said, they're a little bit shorter. There's no engineering news, no ads. We get straight into the episode. Definitely still has the tangents that you know and love from us, especially when we get talking about trains. We have a really long tangent about trains on one of our recent episodes about the Cantera loop. Yeah, so they're really fun to put together. We're kind of calling them Failurology Light. They're like a lighter, shorter version of our regular episodes.
Yeah, I have a lot of fun recording them because there's a lot of cool things that have happened and things that have failed that just don't have enough content to make a full 45-minute episode that you're all used to listening to.
Yeah, they're pretty cool, and it's only $5 a month. So please check that out. If you want to take full advantage, wait till the beginning of December, and then you can pay $5, and then you can listen to all the episodes we have in December. And if you don't like it, which I don't think would happen, you could unsubscribe. But hopefully you stick around. We'd love to hear from you. And that's just kind of what we're doing with that now. I think we have a lot of ideas for the Patreon, but this is kind of where we're starting. This week's engineering failure, I will say, has a lot of content, so we're gonna jump right in because there's a lot to cover. But before we do that, Brian, what's the news?
I have some great news about Lego. Lego, that you all know and love and hate to step on, they have decided that they are going to run 100% off of renewable energy, which is really cool because they make 75 million Lego bricks a year. It took them 4 years and $900 million US and an investment in 2 offshore wind farms. So the total power generated from the renewable sources exceeds the energy consumed at all the Lego factories, the stores, and all the offices globally. So this is really a net win for everyone. You still get Lego. It's all renewable energy now. So in the past, there were 360 gigawatt hours of energy used to produce 75 million Lego bricks. They installed 20,000 solar panels on the roof of the Lego factory in China, producing 6 gigawatts of energy per year. There were 3,500 solar panels installed in the Czech Republic factory, so that reduced CO2 emissions by 500 tons annually. They installed an innovative new cooling system at their Danish factory to use outside air to cool the production process of molding Lego bricks. This is instead of a refrigerant-based system, providing an energy reduction of 538,000 kilowatt hours, which is equivalent to a savings of 111 tons of CO2 emissions a year. These are a lot of energy savings that they've implemented.
Definitely.
They also did a couple other things. They weren't done yet, so they changed the entire lighting system in the Lego factory in Mexico to 19,000 high-efficiency LED bulbs across the entire production floor. That was a reduction of 1,300 tons of CO2 emissions annually. Lego is also working with its supply chain to reduce carbon emissions, water use, and forestry impacts. The Lego campus in Billund, Denmark, which opened in 2019, they used strong plasterboard to save 22,000 kilograms of steel and 353,000 kilograms of CO2 emissions. 4,000 solar panels are on the roof there, and those produce 1 million kilowatt hours of energy annually. So all around, Lego is invested in this full on to reduce their CO2 emissions, just conversion to renewable energy. So the next time you step on a Lego brick, just think it was made from renewable energy.
I think another big thing, another important item to note is that they have ownership stake in 2 offshore wind farms, one in Germany and one in Liverpool, which has a total power generation of 570 megawatts. So when I see the headline that says Lego's operating on 100% renewable energy, I'm wondering, Well, how are they doing that? They have stores in malls. How are they controlling that power source? And how are they dealing with all of these little satellite buildings and offices and things that they have? And what Lego has basically done is they've calculated how much energy that they're consuming on a given year, and then purchasing stake or doing things to offset that energy with renewable resources to kind of equate the same amount of energy that they're using. So they're not actually going to every single store and putting solar panels on the roof, but they're investing in wind farms. They're putting solar panels where they can in the factories that they own. They're changing their light bulbs to a more energy efficient bulb. And I just think that's a really interesting way to do it. There's a lot of creative ways that we can get to a 100% renewable energy source, and they don't all have to be complicated. So I think this is really creative. Lego's kind of taken a multifaceted approach. They've kind of attacked a bunch of different prongs all at once and made a really big impact. And Lego's not a small company. They're really big.
Yeah, they have billions of dollars in revenue a year. They've been around for 70 plus years, 60 plus years, a substantial amount of time. They have a global reach and a global impact. They're sourcing things from around the world. And I don't think it's a product that will just suddenly go away. They've diversified some of their product lines into Harry Potter Lego or Star Wars Lego, and they're coming out with some really neat kits in the future. They have a massive Titanic that's almost 1.5 meters long. So I don't think Lego's going away anytime soon. So to see a large company like this investing in renewable energy for the future, I think that's a very positive step.
Yeah, I think they're industry leaders. They're showing other companies that this is possible and that they can do it too. And if anyone listening is thinking that this is a publicity stunt, well, there could be some of that. I don't really care. They're doing a good thing, and if they need to feel like it's a publicity stunt to do it, then so be it. They're still making better choices. I'm not saying that they are doing it for publicity alone. That's not what I'm saying, but there is this perception that that's why some companies do that. And I personally don't really care. You're making good choices. You're switching to renewable energy sources. I don't really care how you get there as long as you get there.
If you want to learn more about Lego's renewable energy program or just Lego in general, check out our show notes for more information and links to the Lego website and to the press release that Lego issued that speaks about Lego going to renewable energy.
And you can find all of those links on our website at failureology.ca.
This week's episode of Failureology is brought to you by the Sit Down Stand Up Paddleboard Company.
Whether you like to sit down or stand up,
the Sit Down Stand Up Paddleboard Company has something for you.
Don't miss our paddle sale. It's quite the ordeal. Now on to this week's engineering failure, the 2003 Northeast Blackout. If you listened to the last episode, A Year in Review, we talked about a lot of different things that we've learned on this podcast and things that have changed because of this show. But one thing I did mention was that, and why I was really excited about this episode, was because I lived through this blackout. I grew up in southwestern Ontario. I remember this blackout. It was very weird. So I'm really excited to do this one. This one definitely hits close to home for me. So it happened on August 14th, 2003 at around 4:10 p.m. Eastern Time. This blackout impacted a lot of areas. It impacted several states: Ohio, Michigan, Pennsylvania, New York, Vermont, Massachusetts, Connecticut, and New Jersey.
That's a lot of states. That's a large swath of people to be impacted.
Yes, as well as a large portion of the province of Ontario. So all in all, this impacted 55 million people. And this blackout took 508 generating units at 265 power plants offline during the outage. We're going to get into how that happened a little bit later, but essentially to prevent overloads, a lot of the plants had to shut themselves down or take themselves offline to prevent catastrophic damage from occurring.
I mean, even to have 250 plus power plants shut down, that's an impressive number.
Impressive in a bad way.
Oh yeah, impressively bad, but still impressive.
Yeah, so parts of Ontario suffered rolling blackouts for more than a week before power was restored. If my memory serves, I think we were out of power for at least 2 full days, and then we had what we referred to at the time as brownouts. So we would have power losses kind of sporadically throughout the day for maybe an hour or two at a time. That kind of carried on for about a week. So it was definitely not a quick flicker. The cost for this blackout was between 4 and 10 billion US dollars, which is a huge amount of money. And it resulted in a net loss of 18.9 million work hours.
And this was almost 20 years ago as well. So I think if this happened today, it would be significantly higher. Back in 2003, a lot of people probably still didn't have high-speed internet. We certainly didn't have massive server farms and cloud computing and cloud storage needs. So yeah, I think if this happened now, it would be substantially higher.
I will say too, there's a lot of manufacturing that happens in this part of North America, in Ontario, but as well as a lot of the states that I listed. And so a lot of those work hours go to factories just not being able to operate because they have no power. At the time, this was the world's second most widespread blackout in history after the 1999 Southern Brazil blackout.
All right. We're going to talk about the sequence of events.
Thank you, Wikipedia.
It's pretty long. It's pretty detailed. We're not going to go through a second-by-second synopsis of it. Those will be in the show notes. But if you're not sitting down, maybe sit down, grab a drink of your choice. We're going to be here for a while. So the blackout starts at 12:15 p.m. A power flow monitoring tool goes down. An operator corrects the telemetry problem that caused this issue, but he forgets to restart the monitoring tool. And this kicks off a fairly disastrous chain of events. At 1:31, an East Lake, Ohio generating plant shuts down. This plant is owned by First Energy, which is an Akron, Ohio-based company. First Energy is going to show up a few more times in this. And then at 2:02 p.m., the first of several 345 kilovolt overhead transmission lines in Northeast Ohio fails due to contact with a tree in Walton Hills, Ohio.
This is going to be a common theme, this tree problem.
Yes, it is a very common problem. 12 minutes later at 2:14 p.m., an alarm system fails at First Energy's control room and is not repaired. In just under 2.5 hours, we've had a number of things fail that shouldn't have failed, and also some things that go off that should have been reset that aren't reset or repaired. At 3:05 p.m., another 345 kilovolt transmission line, which is known as the Chamberlain-Harding line, sags into a tree and trips in Parma, which is south of Cleveland, Ohio. 3:17 p.m., the voltage dips temporarily on the Ohio portion of the grid. Controllers don't do anything.
In their defense, do they deserve it? Maybe not, but they also, I don't think, knew that this was going on. I don't think they knew that any of this is going on. So we're almost 3 hours into this, and the operators have no clue that any of this is happening. They don't even know this is happening until they're in the midst of the blackout, which is crazy. And we're going to get to that. I'll stop interrupting you.
No, it's fine. So at 3:32, power shifted by the first failure onto another 345 kilovolt power line. This one, the Hannah-Juniper interconnection, causes it to sag into a tree. That brings it offline as well. While systems personnel and power controllers concentrate on understanding the failures, they fail to inform system controllers in nearby states. And that leads to other issues.
So the controllers, they kind of know what's going on, but the people in the operating room don't really know what's going on. They don't really see the problem yet. And then there's absolutely no communication to anyone outside of First Energy in Ohio, which is really unfortunate. So at 3:39 p.m., another line trips, and this one's in northern Ohio. 2 minutes later, another trip happens. And then 15 lines fail in rapid succession, also in northern Ohio. And then this kind of goes on for the next 25 to 30 minutes. Several of these lines are tripping in Ohio, but eventually this does start spilling over into other areas. So by 4:10 p.m., many transmission lines have tripped out in Michigan, Ohio, blocking eastward flow of power around the southern shore of Lake Erie from Toledo, east through Erie, Pennsylvania, and into southern Erie County. But it hasn't quite gotten to Buffalo, New York yet. So as all of these lines are going offline, this load then transfers to other lines that are available. So essentially, it's kind of redirecting itself to other lines that are available. But then those lines get overloaded, and then those stations start to go offline, which ends up creating a huge power deficit. And in seconds, the power surges in, overloading the East Coast power plants, and those generators go offline as a protective measure, and we're in a blackout. So we're still at 4:10 p.m. This all kind of, the build up into this failure took a few hours, but then within a matter of minutes, everything just kind of trips out. The eastern and western Michigan power grids disconnect from each other, and several lines continue to trip throughout Michigan.
Still at 4:10, this is 4:10 and 38 seconds, Cleveland, Ohio separates from the Pennsylvania power grid. A couple seconds later, 3.7 gigawatts of power flows from the east along the north shore of Lake Erie through Ontario to southern Michigan and northern Ohio, a flow that is more than 10 times greater than the condition 30 seconds earlier, causing a voltage drop across the system. Flow flips to 2 gigawatts eastward from Michigan through Ontario, which is a net reversal of just under 6 gigawatts of power, then reverses back westward again within half a second. So in not very much time, really over a couple seconds, we have massive surges of power, they're changing direction all the time. International connections between the United States and Canada start to fail. A couple seconds later after that, northwestern Ontario separates from the east when the Wawa Marathon 230 kilovolt line north of Lake Superior disconnects. This is the first Ontario power plant that goes offline in response to unstable voltage and current demand on the system. A couple seconds after that, New York separates from the New England grid. A few seconds after that, Ontario separates itself from the western New York grid. Seconds after that, more lines fail in Michigan and Ontario. Windsor, Ontario, and surrounding areas drop off the power grid. Northern New Jersey separates itself from the power grid a couple minutes later. Everyone is just not having power in all of these places. So from this kind of cascading system of failures and grids disconnecting from each other, this causes a cascade of failing secondary generator plants along the New Jersey coast and through the inland regions and west. And finally, at 4:13, so 3 minutes after stuff got really bad, this is the end of all the cascading failures through the northeastern states and Canada. In summary, 256 power plants are offline by this point. 85% of them went offline after the grid separations occurred, mostly due to the action of automatic protective controls.
I think we all can agree this is a pretty extensive failure. It's a lot of damage, but what was the actual impact? Some essential services remained in operation, although not all. Some backup generation systems failed. Telephone networks generally stayed online, but there was so much demand that a lot of the circuits were overloaded. So I don't know if you live in an area that experiences power outages often, but growing up in Ontario, we experience a lot of thunderstorms living on the Great Lakes. Almost every time the power's out, you're calling up your neighbor, you're calling up your family. Do you have power? Do you have power? Do you have power? And so I think that was probably what was happening. Everyone's chatting with everyone else. I mean, you can't really do anything else.
Yeah, and this was also really like certainly pre-smartphone era, and I also feel probably pre-cell phone for a lot of people.
Yeah, so interestingly enough, we had a lot of cordless phones, but they didn't work because they require power. And so we only had one phone that worked, and it was a rotary phone. I don't know if you guys are familiar with rotary phones. You have numbers on a dial, and you have to basically turn them for each number individually. It's kind of annoying to dial, especially if you mess up right at the end. And so we had one working phone in our house for a few days, which was really interesting. And it was corded, so that kind of sucked. You get used to the cordless phone. We're spoiled, and then we go back to corded.
One of the things I never understood about rotary phones, for dialing 911, you had to turn the dial a long way for 9 and then let it spin itself back before you could dial the ones. That doesn't seem like a great number to be dialing on a rotary phone.
That's a really good point. I wonder how many people are listening have never used a landline. I have a coworker who just started with us, and he had to use the landline, and he's like, how do I dial out? And I mean, in his defense, if you've never worked in an office before, you have to push 9 to get an outside line. But it was just funny because I asked him, have you used a landline in a while? And he's like, it's been a very long time.
No, it's a valid question, because I've worked at places where it's been 9 to dial out, but then I've worked other places where it's been 4 or 7 to dial out. So I feel that is a valid question.
That's fair. I've only ever had it be 9. Anyways, water systems in several cities lost pressure because their pumps weren't working, which led to some backflow conditions and a lot of boil water advisories, which also sucks because if you have an electric stove, you can't boil water because you have no power. So that was tricky. If you haven't checked out our Flint episode, please do so. It's number 12. It's not necessarily related to water pressure loss or a large blackout, but it's definitely related to boil water advisories. It's also took place in Flint, Michigan, which was affected by this blackout. So it's a really interesting episode. Please check that out. Episode number 12. The blackout also released 140 kilograms of vinyl chloride from a Sarnia chemical plant, but no one knew about that for 5 days. In New York, Newark, New Jersey, and Kingston, amongst other places, sewage spilled into waterways, requiring beaches to be closed, which is really gross, but it happens. Several gas stations were unable to pump fuel, leaving cars and transport trucks stranded. There was apparently a bunch of trucks stuck in northern Ontario trying to head west, but they didn't have enough fuel to get to the next gas station in Manitoba, so they were kind of trapped there. Cell service was also interrupted due to increased volume of calls, leading to overloading. Some radio and TV stations stayed on air with the help of backup generators. Amtrak, which relies on electricity for signaling and crossing systems, shut down, but Via Rail, which is the Canadian version of Amtrak, or Amtrak is the American version of Via Rail, it continued to operate. All airports in the blackout area shut down, and flights were diverted to airports without power. They couldn't operate the control tower because they didn't have any power. The New York City subway was down for a few hours, but it did resume around 8 p.m. And so all of these are bad things, definitely. None of these are really good. But one thing that was interesting, or at least a silver lining, was that stars and orbiting satellites became visible to the naked eye in a lot of really populated cities because there was no more light pollution because all the streetlights were out, which was definitely something that I experienced. I remember walking down the street at night, and it's very black, obviously, because there's no streetlights. But you could see so many stars, which was really cool because there's no light pollution. And I think, I grew up in a small town, so I would imagine that in, a large city like Toronto, that would have been a really, really interesting thing to see and be a part of.
Yeah, and it's really neat, especially if you've grown up in a city or an area where there's lots of light. If you do have the opportunity to go into a dark sky preserve or a dark sky area where there's no light interference or where there's very minimal light interference, the amount of stars that you're able to see is staggering.
Very cool.
I highly recommend that if you ever get the opportunity. To prevent damage from an overload event, nuclear power plants went offline until they could be slowly taken out of safe mode, which seems like a really good idea.
Yeah.
The Bruce nuclear generating plant was able to throttle back their output without a complete shutdown, then reconnect to the grid 5 hours later, which probably helped out a lot of things. Any available hydroelectric, coal, and oil-fired plants came online fairly quickly and were able to provide power to the areas immediately surrounding the plants. Some other pockets were able to avoid power outages by disconnecting from the larger grid. And at one point, like Nicole mentioned, there was a number of trucks that were stuck, and there was up to a 7-hour wait for trucks crossing the Ambassador Bridge between Detroit and Windsor.
So the Ambassador Bridge, or the tunnel crossing between Detroit and Windsor, I think that's the busiest international crossing. At least it's definitely the busiest in North America. It might be one of the busier ones in the world. 7 hours, though, is a long time. So following 9/11, the wait got to be 3, 4, maybe 5 hours to get across. Nowadays, it's usually 30 to 60 minutes to get across if you time it right. If you go while everyone's crossing to go to a football game or a hockey game, then your wait will probably be a little bit longer. But if you time it right, it's not quite that bad. 7 hours is a long time. I've never waited that long to cross. I would not go. It's not worth it. That's your whole day.
Yeah, actually. Yeah, so the Ambassador Bridge crossing, I think it's the Ambassador Bridge crossing. They do have a marathon or half marathon, I think, that goes between Detroit and Windsor, which I think is a really cool way to run something like that.
Yeah, I've done that one twice. You start in downtown Detroit, and then you cross on the Ambassador Bridge. You run through Windsor, and then you cross back through the tunnel, which is really cool because neither of those crossings are pedestrian crossings. The only way to get across those is in a vehicle. So if you are a pedestrian, you have to take what we call the tunnel bus, and you have to basically get on a bus on one side, and that's how you cross the tunnel. I don't think there's anything on the bridge side. So to be able to run across it is really, really cool. Plus, you get to see a lot of stuff. Yeah, I love that race. I would have done it again this year, but COVID. That
is really cool. So when you do this race, do you run with your passport, or is it kind of a pre-clearance thing, and they just hope for the best that you're not going to stay in one of the countries? How does that work?
There's a pre-clearance. You have to show your passport to get all your race gear. You have to have your bib present at all times. There's a lot of border guards at each of the crossings, making sure that everyone crossing is wearing a bib. Your bib also has a locator, like a GPS on it that tells them where you are. And they also recommend crossing with your passport, which I do, but I have never had to pull it out. So I bring it with me because in the middle of a race, I don't really want to get like stuck and have to be like and not have my stuff with me. So I've always brought it with me, but I've never had to use it or show it.
Yeah, and plus the passport pretty light to carry. It sounds like they've taken reasonable precautions, I think, for border security patrol and GPS tracking and bib numbers. And I'm sure they have people that are on various buildings watching for people that are going to take their bib off mid-race and try to stay in contact. Either way, that sounds like a really, really cool marathon, half marathon race to participate in.
Yeah, it's really fun. I like it a lot. It's my favorite one.
Maybe you can run it again next year.
I actually am. I registered at the beginning of 2020, and then my registration, I had to defer it, and I didn't think we would have our ducks in a row in 2021, so I actually deferred to 2022, which worked out really well because they didn't do it international this year, and I probably wouldn't have done it because crossing to the States seems like a real big pain in the butt right now. There's all this testing
true.
and
I can confirm that.
Yeah. I mean, it's not impossible. It's not that I don't want to go. It's just there's so much hassle. I don't want to go bad enough to deal with it. I'll just wait.
Well, I hope you get to run that in 2022. That sounds, super cool.
Me too.
So streetlights, since they're operated by electricity, there are a lot of streetlights that were out, leading to a lot of traffic being backed up. Some cases, members of the public started directing traffic until they were relieved by the police. There were 140 miners that were marooned underground in the Falconbridge mine in Sudbury when the power went out, which sounds terrible.
Mm-hmm.
A refinery scrubber at another site in Sarnia lost power, and it released above normal levels of pollution. There were a ton of 911 calls for fire, mostly from candles. In New York City specifically, they had more than double the average calls for help. So all of these issues, I mean, the whole incident really happened over 4 hours, with the bulk of it happening really in about 5 minutes or less. It's leading to all these compounding problems.
There's definitely a huge impact. I mean, we just went through it all. There's a lot of unfortunate things that happened. On top of that, there were, at least as far as we know, 12 deaths reported from this blackout. Some of them were from carbon monoxide poisoning. Some were from people being hit by cars. Some were from fires. One gentleman, unfortunately, he had a really, really severe burns, and it was reported that he died because he wasn't able to regulate his body temperature properly because his AC didn't work, which sounds really sad and unfortunate that happened. So what happened? What was the cause? We know that there was, I mentioned software bugs, and there was a lot of overgrown trees that the power lines ran into, and a lot of lines that had failed. But kind of what was going on behind the scenes that led to this blackout? On the day of this blackout, it was 31 degrees Celsius, leading to a lot of energy demand as everyone turned on fans and air conditioners trying to stay cool. As the energy demand increased, the power lines started to sag as higher currents heated the lines, and then these sagging lines lowered and lowered until they ran into the trees, creating additional problems. The proximate cause, which is the one that the law recognizes as the official cause, and I will say that there are several factors to this blackout, and there is not one singular cause, but the one that the law recognized as the official cause was a software bug in the alarm system at the control room of First Energy in Akron, Ohio. I kind of alluded to this earlier. There was a software bug in the alarm system that essentially prevented any of the alarms from showing up on the operator's computers. On top of that, there was human error, equipment failures, and other software issues all to blame. The software bug itself rendered operators unaware of the need to redistribute the load after the overloaded transmission lines dropped into the foliage. So what would normally happen was if they lost some of the transmission lines, they would redirect that load to other places. But since they had no clue what was going on, they weren't able to do that. And the loads just kind of redistributed themselves until they just continually took out line after line. This definitely was preventable, but even if the transmission lines had started to collapse, they still would have managed to keep the system online. But due to the software bug, it basically turned into a collapse of the entire regional distribution. And what ended up happening was that at 4:10 p.m. specifically, a 3,500 megawatt power surge affected the grid. Right before the blackout, the system was carrying about 28,700 megawatts of load. And at the height of the outage, the load dropped to 5,700 megawatts. So they lost about 80% of their capacity, which is huge. Because overloading can cause such costly damage, an affected device is disconnected from the network if an overload's detected. And so that's why a lot of the power plants went offline, to prevent themselves from overloading. So once that overload is detected, automatic protective relays disconnect the line and transfer the load to other lines. If the other lines don't have enough spare capacity to accommodate this extra current, they also overload, and then this kind of cascades down the line until we have full-blown blackout.
Yeah, so when this is happening, power plant operators, they have to basically shed the load or obtain more power from generators until they can rule out whether a system collapse will happen or not. Unfortunately, in this case, they weren't able to do that. And then in an emergency scenario, they're supposed to immediately shed load to bring the system back into balance. In order to help operators detect overloading, there's a number of computer systems that issue alarms when there are faults within the system. Power flow modeling tools let operators analyze the state of their network, predict any overloading, and predict failure points, which should allow them to change the distribution of generation and reconfigure the system to prevent a failure. If these power systems and backups fail, the operators have to monitor the grid manually. If they can't interpret the state of the grid, they follow a contingency plan, contact some other power plants, other grid operators by phone if they have to. And they also have to notify nearby areas which may be affected so they can predict effects on their systems as well. Since all of these systems are so interconnected, a failure in one part of the system, or even a system that might go offline soon, that's going to impact a ton of other power plants and power grids and people in different demographic areas like we've seen here.
Yeah, and since the software bug prevented them from seeing any of these alarms, they weren't even able to roll with this contingency plan until the grid had basically gone down, which is really unfortunate.
And really, by that point, it's probably too late for this, right?
And we're going to talk about this shortly, but I mean, even as far as the contingency plan, it wasn't really clear what they were supposed to be doing. Everyone kind of had a different idea for what the plan was. So, I mean, there was a lot of problems with this outage. Luckily for us, there was a formal investigation. This is our favorite part, our highlight. A joint federal task force was formed by the US and Canadian government, and it was led by Canadian Natural Resource Minister and the US Energy Secretary. Their role was to determine the initial cause and examine the failure of safeguards designed to prevent such a failure from happening. Ultimately, the US didn't seek federal level punishment towards First Energy Corp, even though they were found to be responsible, because at the time, the US law didn't require electric reliability standards, which is honestly crazy to think about, that you wouldn't have any type of reliability standard built into your energy rules.
We've seen this time and time again, I feel, through a lot of these failures, is what you would think should have been built in or should have been thought of right away isn't really thought of until you have something that's a fairly catastrophic failure that happens.
Yeah. So luckily this changed in 2005 when revisions to the Act came into play. Although I'm not quite sure how robust they are, and I'm basing that on what happened in Texas just last year in 2020. I realize Texas is a different state, and so perhaps some of these rules are state by state or they're leaving it up to the corporation. And to be fair, I haven't read the report on the power outages in Texas, and I don't know the full scope of that failure. But I have to assume that these revisions that improved reliability standards were not as robust as they should be. That said, it's hard to know how many catastrophic failures were prevented because of this one, whether that's changes to the rules or corporations doing their due diligence to prevent this from happening. And that's because we only really hear about the failures that happen, not about the ones that almost happened.
I think if it even prevented one catastrophic failure, that's a pretty good thing. If one catastrophic failure has been prevented, that seems like a pretty good trade-off.
Yeah.
Out of the investigation, there were a number of key findings that came out, and I'm going to summarize these findings here because I think these four are probably the more important ones that come out of this investigation. First Energy Net's Reliability Council, quote, failed to assess and understand the inadequacies of First Energy systems, particularly with respect to voltage instability and the vulnerability of the Cleveland-Akron area, and First Energy did not operate with appropriate voltage criteria. Secondly, First Energy, quote, did not recognize or understand the deteriorating condition of its system, end quote. That's clearly evident in kind of the schedule of events that we went through. Things happened fairly quickly, and they didn't recognize that the system was starting to fail. The third finding from the report was that First Energy, quote, failed to manage adequately tree growth in its transmission right-of-ways, end quote.
So one of the interesting things that I read here is that there were very clear-cut, pun intended, rules for clearances to several obstructions. But one thing that was weird, I thought, was that clearances to vegetation was different state by state, by province, individual utility companies. Everyone had different rules for what the clearances were to vegetation. And I think that gray area is part of why some of these trees grew too close to the power lines, because those rules weren't clear, and I don't think they were overseeing that as well as they should have.
Yeah, so vegetation encroachment on power lines, especially transmission right-of-way lines, is a thing that needs to be managed on an ongoing basis, kind of year-to-year programs. There needs to be identification of what trees are too close to the right-of-way or too close to the power lines. They need to be trimmed back. That needs to be managed. And we even see this nowadays. I believe it was last year, the year before, there was a large fire in California that was caused by trees contacting power line. They'd grown too close to the power line, and it created, again, massive blackouts and substantial damage to electrical grid infrastructure, just because the vegetation encroachment wasn't managed properly. The fourth finding that came out of this was, quote, the failure of the interconnected grid's reliability organizations to provide effective real-time diagnostic support, end quote. So those are the four kind of key findings that came out of the council report. All of them, I hope, have been addressed at some level so that this doesn't happen again in the future.
So the report outlined as well some additional issues. A generating plant in Eastlake, Ohio, which is a suburb of Cleveland, went offline during high electrical demand, which put a strain on nearby high voltage power lines, and then later went out of service when they came in contact with overgrown trees. Those lines transferred their load to other lines, which couldn't handle the load, tripping the breakers. When multiple trips occurred, several generators lost parts of their load, accelerating out of phase with the grid at different rates and tripped out to prevent damage, which led to the forced shutdown of 265 power plants. So that's a quick summary of basically what we've been talking about. You know, one thing happened, it put all of its load on the lines around it, and then those went down, and then it just kind of cascaded from there. So the software bug is known as a race condition, and it existed in the energy management system. And this bug stalled alarms for over an hour. So the system operators, like I said, were not even unaware of the malfunction. They had really no clue what was going on. Everything looked fine to them. And then these unprocessed alarms queued up in the primary server, which failed within 30 minutes, and the backup server failed after that. And by about 3:40, the control room itself lost power, and the operators informed technical support, although for some reason they knew about the issue because they were already trying to troubleshoot it. So there seems to be a huge communication breakdown between all of the different players at First Energy and at all of the other power plants around the area. And to be fair to them, during times of what I'm assuming is crisis, you know, you have your power plants are shutting down, your grid is going offline. Maybe you're not thinking about calling your neighbor to see what they're up to. You're probably just trying to get your grid back online.
There's a lot of things that are happening in a really short period of time that none of these operators would have seen on a day-to-day basis, and likely wouldn't have even seen in like an emergency training scenario either. Tons of catastrophic things happening in a very short period of time.
Yeah, and like I mentioned, they had different interpretations of the functions, responsibilities, authorities, and capabilities needed to operate the systems, and there was no effective protocol for sharing information, even within the control room, let alone with others outside of the control room. So even the people that are all in the same space aren't communicating effectively, let alone those people communicating with other people. And we're talking about, you know, several states. Ontario is a huge province, over 250 power plants, and there's just no one's talking to each other. Also, and this is something I thought was really interesting, the models that they used to view and forecast loads weren't accurate. They weren't verified through benchmarking with actual data and field testing, and they weren't peer-reviewed or shared amongst operators. So
this seems like a really important thing that you should be doing.
It seems like a really, really important thing and a huge oversight that their model data was basically educated guesswork at best. They weren't using any real data. And there was also no effective load reduction plan or adequate load reduction capability to relieve the overloaded lines. So yes, they could, quote, shed load, but there was no really good plan to do that aside from shutting everything down. There was no way to kind of safely take the system offline. The items that we've mentioned, such as poor vegetation management, operator training practices, and the lack of adequate tools allowing operators to visualize actual system conditions, these were factors in prior large-scale blackouts. So these were things that had happened before. They had led to blackouts before. We knew they were a problem, and we didn't fix them. History always repeats itself, and it's important to take a step back when these failures happen and look at all of the things that go wrong and do what you can to put redundancies and checks and balances in place to prevent them from happening again. And it's really unfortunate that this didn't happen. And I mean, again, looking at Texas, this still didn't happen. I don't understand how people can just not ignore it, just because I don't understand. It's really frustrating, honestly, to read some of these failures and see, a lot of the things that went wrong seem pretty straightforward to me. They were ignored, caused this huge blackout. And then, yeah, some things were corrected and maybe things were great for a little while. But as Brian mentioned, this happened almost 20 years ago, which in itself is crazy to think about. And we still have large scale blackouts happening in North America. It's like we didn't learn from this failure, at least not everything that we could have learned. Maybe we learned some things, but we didn't learn enough.
There were some long-term effects from this blackout. The U.S. included reliability provisions in the Energy Policy Act of 2005. Perhaps Texas missed that memo. More on that in a future episode.
Yes, I definitely will be reading into the Texas blackout, and I would love to cover it on a future episode, but not right away. I think I like to spread them out a little bit.
We'll power down doing that episode.
Safely.
In the near future. Not only was there an infrastructure problem, but they also deemed it a homeland security problem, as most of the systems that were used to detect unauthorized border crossings or port landings failed without power, which seems like an issue if you're trying to prevent or monitor people getting into your country or you want to know the status of your border. This became a big political issue for Ontario, whose Conservative Premier, Ernie Eves, did not want to expand the province's power generating capabilities, therefore relying on the US for power.
Yeah, I don't know too much about the power generation in Eastern Canada, but I know a few things. And one of the reasons that Quebec didn't go offline is that Quebec, I believe, has a lot of its own power generating facilities. And I believe, if anything, Quebec is selling to some of the states. And Ontario chose not to diversify, and they chose to continue relying on the states, at least at that time. That has since changed, I will say. There are a lot of wind farms in Ontario, Southern Ontario for sure. There's a lot more solar. There's a lot of hydro as well. You've got Niagara Falls, as well as some other hydro plants. You've got the Bruce Nuclear Power on the Bruce Peninsula, which is kind of on the west side of Ontario. So they've definitely diversified a lot more since this happened. I think they saw a big flaw in their plan to rely on the US or at least rely on other areas that they don't have control over for their power source. And so it's nice to see that they've diversified. I don't think everyone's happy about the windmills. I hear a lot of complaints from family members. I think they're getting used to them, but I don't think they love them. So it is what it is.
I can understand that. Like, the windmills are large structures. They're fairly noisy. I didn't actually understand how large the windmills were until I worked on a windmill project and then hiked right beside them. These are massive structures that a lot of time are in very scenic landscape.
Yeah, but I will say too, in Alberta, our summers, yeah, they get hot, but they don't get 45 degrees with the Humidex hot. You can't function in Ontario. I mean, you can survive, but it's not pleasant in the summer without air conditioning. So, and that's only becoming worse and worse as climate change gets worse. And so pressure on the grid to keep up with the loads is just getting higher and higher. And so it's really good that they've done something about it. And I'm glad that they did it with, renewable energy sources or clean energy sources and didn't just add a bunch of coal-fired power plants like we sometimes do in Alberta. Although we're not adding new ones, but we definitely still have some in existence. So the investigation came up with a number of recommendations. There were 46 in total. I'm not going to read them all, but there were some that I thought were important and or interesting, so I want to share those with you. First and foremost, they want to make sure that reliability standards are mandatory and enforceable, and there's penalties for non-compliance. And I think they did try to do that with the changes that they made in 2005. And then these standards, at the time they said these standards should be developed by a third party with fair stakeholder representation in the selection of the directors and the committee. So they didn't want to put each of the utility companies in charge of making their own rules. That never goes super great because their focus is different. They're often looking at their bottom line. They're looking at how can we make money? How can we save money? And you need kind of people with a more objective mindset that's looking out for public safety as well as costs, kind of looking at the full picture to make those recommendations. They also recommended allowing investments in bulk system reliability to be recoverable through transmission rates. They wanted to protect operators who shed loads as per approved guidelines from liability or retaliation. And I hadn't thought about this until I read this recommendation, but I have to imagine there would be some backlash for any operator who shed loads, even if they had to, because of cause issues in other areas or, reduce potential revenue for their company. And so they had, in order for this to work and for operators to be able to actually do the load shedding, they have to protect them from that type of retaliation.
Yeah, that's probably a good thing to have in place, and especially if it's a more junior operator, or if they see the larger impact that shedding would have, or don't want to deal with senior management people asking why they made a decision. That's a really tough thing to do, to put a process like that into place that possibly may disrupt power for some people, or certainly impact company revenues. But by doing it, you're saving disruption to millions of other people in this case.
Mm-hmm. They also recommended to standardize vegetation clearances and enforce them, which I hope that they have done and are enforcing. Improve the research for both reliability monitoring and modeling methods and technology. Establish clear authority for physical and cybersecurity. And lastly, install backup generators at nuclear power plants. Nuclear power plants can't just shut off in a matter of minutes, so those all had to be pulled off the grid in order to protect them from essentially a nuclear meltdown. If they had some kind of backup generation, those would have allowed those plants to still at least provide some energy to the grid so they wouldn't, cause a full-blown blackout. There'd probably be some downtime because generators usually take a couple minutes to get turned on and up to speed, but it would at least allow them to keep the grid kind of limping along until those power plants
at a functional level. Yeah,
until those power plants could come back online.
So there you have it, the 2003 Northeast Blackout. A really hot day with lots of air conditioning units running, some overgrown trees, and a software bug that knocked out power to a large portion of the Northeast US and Ontario.
For photos, sources, and an episode summary from this week's episode, head to failureology.ca. If you're enjoying what you're hearing, please rate, review, and subscribe to Failureology so more people can find us. If you want to chat with us, our Twitter handle is @Failureology. You can email us at thefailureologypodcast@gmail.com. You can connect with us on LinkedIn, or you can join our Patreon page. Check out our mini failure episodes. Check out the show notes for links to all of these. Thanks everyone for listening, and tune into the next episode where we'll tell you all about the Charles de Gaulle airport collapse in Paris, France. Bye everyone. Talk soon.